I'm going to talk about memes and fitness landscapes, a couple of ideas that occurred to me from thinking about science that I hope might illuminate the debate about schools and whether they're a useful concept and what we do with them. So here goes. I've got really too many slides for 15 minutes, but some of the background I think is essential to understand what I'm on about towards the end. So I'll go pretty quickly through the first lot and then slow down towards the end and leave at least 5 minutes for discussion. You heard a bit about the schools this morning. That was the view that I got from Brett Petticord's original Four Schools presentation and also some debate that went on Kem Kaner's blog and in some other places. So four original schools and then the context-driven school. Agile was later called test-driven. The factory school was kind of identified later on. And there was a huge amount of debate a couple of years ago on the blogs, and there was the concept of being oblivious to what school you were. The Groucho school, you don't want to be in any school at all. Potentially axiomatic schools, neo-holistic. So a lot of fun could be had with that. Why do I want to use the science analogies? Well, to hopefully, as we heard a bit about this morning, so that the different schools can understand each other slightly better than perhaps they do, and to hopefully broker a more detailed and structured debate and perhaps a little bit less emotion. Also thinking forward, thinking about the way science has evolved and how it's changed since I was at school and even since I was at university, what the evolution of science can tell us about the way software testing might evolve. The computing and the things that it's used for are exploding dramatically, and can we learn anything from artificial intelligence techniques and the way science is evolving more into the social sciences to help us in testing. I did a precursor talk which was actually about science, which Michael Bolton mentioned a good bit this morning. He mentioned the check test debate, and I spotted an analogy between testing and experiments, which I didn't spot that. People have talked about it for years, but it really matches up quite well if you think about the Myers approach to testing, trying to find bugs, and the Popper approach, trying to falsify hypotheses. It's a very, very similar structure. The testing checking debate, if you're doing a check, you're just checking against one expected result, whereas if you're testing, there are lots of ways the program can fail, and I got some of that information from Doug Hoffman. So testing a much broader concept than just checking against an expected result. The second analogy I want to use is one of value flow, which again isn't new, but you can think about testing as facilitating value flow through a software development lifecycle. And it took me so long to do that animation. I have to use that in every single presentation that I give. But it's a concept of value in an agile lifecycle being pulled by the customer rather than pushed by people who want to write documents. So value flow, and another way of thinking about it is going through a V model structure, which some of you might not like, but as you go down the left-hand side, arguably you're understanding the problem better, and as you go up the right-hand side, you're understanding the solution better. So again, that's value flow, and I don't regard this as a waterfall or strict V model. I think any life cycle you've got potentially goes up and down through those layers, because you've got layers of specification or oracle of some sort, you've got stakeholders of some sort, and you've got levels of integration of some sort. So I think that structure can be used for thinking about any life cycle. How can you measure and manage it? Well, Mike Smith and I came up with something called a value flow scorecard, which is based on Kaplan and Norton's business scorecard. Haven't got time to go into the details of that now, but it sort of takes 7 viewpoints of quality and then looks at what you're trying to do, how you measure success, and then what you're going to do about it. And the reason I show that is because I'm going to use that later on. What you can also do with them is cascade them. So as you're going through a life cycle, one person's initiatives to do something can become the objectives of the next person in the chain. Another couple of analogies, the Robert Pirsig metaphysics of quality, but that's not important right now. I haven't time to go into that. The other one that I do want to think more about is the structure of science. So one way of thinking about different levels of testing is testing at different scales, analogously to how physics and chemistry and biology and social sciences all work on completely different scales. Layers of science, that's something called the cosmic Ouroboros, which is showing how things, how sort of mankind happens to be in the middle of the range from the very, very small to the very, very large. So I've just picked it up to use it as a sort of logo, really, because it gets across the point that human endeavour and human creativity is sort of exploding out of the top of it, and at each level we get a new platform on which to build, and as I'll come on to explain, testing has a job to do near the top of that. That I believe it or not, I actually drew that before I read Ray Kurzweil's Singularity is Near book, and it just happens to align to his epochs. So what's coming up, if you believe him, is some very, very spectacular things in the future of computing. Even if you don't believe him, if you think there's anything remotely in this, then software testing's got some pretty difficult things to do in the not too distant future. So concept of evolution, everybody's familiar with Darwinian evolution, I assume. Evolution's controlled by genes which replicate and select, and they also mutate. And I've got the analogy of the meme later on, which sort of builds on that. Another way of thinking about evolution, which I got from Dennett's work, or based on Dennett's work, you can think about evolution as increasing sophistication plotted against increasing diversity. And diversity is a concept that we come across quite a lot in technology. Evolution hasn't been smooth. There's been, or it depends who you believe, but there's evidence that there's been sort of jerks in evolution, mass extinctions, long periods of stasis. Species die out from time to time in large numbers. So putting all that together, science has evolved through physics, chemistry, biology, and through to social sciences. As I say, not smoothly, but with discontinuities. So what's it all got to do with software testing? Well, coming out of social sciences, mankind's developed language, developed printing, developed computers. Testing's got a big job to do right up at the top of that, and there are tipping points in the way that's developed as well. Are we ready to test artificial intelligence yet? I'm sure parts of software testing are definitely not, but are we up to that challenge? I haven't time to go through this in detail, but a history of sort of the eras of software testing as seen by Gelperin and Hetzel, going through different sort of ages that were steered by the leading authors through the ages. I wondered if we could reverse engineer the schools onto that, and we sort of can. So Jerry Weinberg, although he doesn't agree with the concept of schools as such, he was arguably the father of the software of the context-driven school. I think everybody acknowledges that, and the other schools more or less align to the Gelperin and Hetzel eras. So can we learn anything from the history of the philosophy of science? Again, there's some alignment with what Michael Bolton was saying this morning. We've gone through Popper, we've gone through Kuhn and paradigm shifts, and we've moved more towards, rather than coming up with a few theories and then testing them, we've come across use of statistics and use of high volume, heavy-duty methods to analyse large amounts of data. And as systems become more complex, we'll need to make more use of that. So perhaps the philosophy of testing can learn from the philosophy of science. So memes, as an extension of the genes concept, genes have taken biological evolution upwards. Arguably, these platforms of human achievement have been driven by something called memes, which are a much looser concept. But here's one taxonomy of them. So memes could be gestures, they could be rituals, spoken word, writing, or other imitable phenomena, which I'll come on to, and they can mutate from symbols to ideas to beliefs to actual practices where you do things. That's an example of some memes that I tried to summarize a few years ago what best practices meant to me for a debate with context-driven at the time, and that was kind of my distillation. So that's about 8 years old now. Another memeplex, if you like, the book Lessons Learned in Software Testing. When I reviewed that at the SIGIST in London, I sort of divided the 297 lessons into what I thought they were about. So a lot of them were about managing, a lot of them were about thinking, about philosophy, about techniques, not much about documentation. Interesting. So that's another example of a set of memes. Now, what I want to do with the value flow scorecard here is to use that as an axis for plotting what I call fitness landscapes. So the standard or control school, taking Kem's description from his blog, that's a lot about standards and processes. That tends to fit that bit. Is there a laser pointer on this? Do you know? There isn't. I'll just use my fingers. So there's a sort of there's a landscape of what it's good at, and the flat bits are where it's arguably not good at those things. And you come on to the analytics school, and it's very good at managing upwards, looking at what developers are doing. It's good at modeling analytical methods and assessing quality, but again, not good at some other things, etc. For the quality school. The factory school, different profile every time. Good at different things and not others. And concept of schools, as I understand it, is that those people are brought up to work in that way. They work in that kind of project, and that's the way they think. So you might call those rugged but fixed fitness landscapes, whereas context-driven is supposed to be flexible and adapt to circumstances. So putting all those analogies together, I'd ask, are these schools meant to be species that aren't allowed to interbreed? Or should they be working more as an ecosystem with the suppliers and with the customers? And shouldn't context-driven, instead of being a separate school, shouldn't it be drawn more as embracing the other schools when the context is appropriate? Those memes I discussed earlier, they can contribute to different peaks. So an example of context-driven thinking is, well, look, that analytics school doesn't seem to know much about, doesn't seem to deal much with the customer or with financial quality. Here are some things that we could use. We could use risk-based testing. We could use the concept of coverage being very flexible to make it a more balanced profile. Classifying memes in those different ways, so the ways testers communicate, papers, blogs, some schools use those a lot more than others. Books arguably go across all the way from symbols to practices, and the best one of all is working on a project where you get all of those different types. So by that measure, working on a project is the best way to exchange memes. So the old schools tend to specialise in books, papers, courses on certification, specific methods, whereas agile and context-driven much more into blogs, conference talks right across. But do people go to the same conferences? At the moment, there's some polarisation in that. Another thing, that the way evolution has gone up through the boundary between order and chaos. I haven't really time to go into that now, but it's another perspective on how evolution actually works. So the message I'm trying to use this to address, I think schools are very, very useful, but perhaps we should be preaching more to the customers rather than to fellow testers about what we're trying to do in context-driven. Try using the meme structure to think about what you're trying to get across and how you're doing it. Particularly sharing our experiences on projects. Testing's evolved and it should continue to evolve, and there could be some quite big leaps around the corner. Number of next steps that I'm considering following up. In terms of the discussion that can follow now, a few questions I've got. Are people stuck in a school for various reasons? Okay. Should take a few more questions you can ask. Reference acknowledgement. Okay. Just about got away with that.
Almost.
Almost.
All right. It's open season. Questions, comments, discussion points? Yes.
If you use the term old school, what were you encompassing everything but context-driven in that term, or I didn't know what you meant? You put it in quotes.
Sorry, I meant everything except agile and context-driven.
Okay.
So analytic, quality, factory, and I mean, Michael talked about mathematical one this morning, which I must admit I hadn't come across, but maybe that's come in some later interpretations. But yeah, I'm meaning everything, but because agile and context-driven seem to have different priorities, but they're definitely new schools. So I mean the other 4 or the other 5.
I just want to extend my congratulations on the heck of a lot of data.
Thanks. Yeah, it was a bit ambitious and you might say foolhardy, but.
Well, never say die.
Is there somewhere to read that later? Is this going to be part of the archive?
Yeah.
Yes, yes, we'll be putting all the slide decks that I can get my hot little hands on. Will be getting distributed out probably to the website. Otherwise, if we can't get it out there, we'll beat up on Ben or Tim or somebody until it gets out there.
I'm sure I could read some of that.
Yeah.
It's like, wow.
Yeah. Yeah, I took quite a lot of sources, and I just kept seeing patterns and then things that agreed, and I kept thinking, stop, enough already. And I thought, well, the message is that there are so many patterns, and they all seem to be saying a very, very similar thing.
All right. Yes.
So you've got a sort of a history of the philosophy of software testing. You make the metaphor with science in general. One of the, I think, alarming lessons for testers coming out of a study of science is that old distinction between the theorists and the experimenters. The experimenters are unfortunately second-class citizens. And guys like Popper who would say, well, the theorists go out there and come up with the great ideas, and then, you know, these experimenters will come along and they'll either show that the theorists will know what they were talking about. And we see it as testers because we do similar work when we get paid less and we're respected less and blah, blah, blah. Do you really see any lessons for software testers based on the history of science of experiment?
Yes, I mean, one of the things I glossed over, but I was kind of having a pop at Popper in a sense, because testers are fond of quoting Popper, but
Popper was not very charitable towards us experimenters.
in philosophy of science terms, Popper is very, very old hat, and the reason I was disagreeing, he had this big thing about falsification, and testers have picked up and say, oh, let's falsify it. The thing they're trying to falsify is the experiment that shows the system matches the spec. What we should be doing is turning it round and making the experiments try to find specific kind of bugs. So the experiment is not to be falsified, the experiment is to actually find different types of bugs using different methods at different levels. And if that means using sort of high volume test automation that I've just heard Harry Robinson talk about and Kem Kane has talked about, if that's using completely different sort of data-rich statistical methods, if it means using indirect methods, because one of the things about science now in physics, it's got to the point where you can't experiment because you're talking about what goes on the other side of a black hole. You can't do an experiment on that. You know, is string theory right? Is quantum loop gravity right? Nobody can show that by experiment yet, although people are trying to think of indirect methods to do it. So yeah, I think the message is we should be turning it round and thinking of the experiments not in the popper sense, but in a more sophisticated sense, and we should be looking for indirect evidence maybe rather than direct evidence.
Very quickly.
I didn't quite follow what you were saying there about, I thought falsification of does the software work as expected was exactly it, and you're saying instead we should focus on a different kind of experiment, and I didn't follow that.
I was suggesting that the experiments we should do should go back to Myers and say that the hypothesis is that the software doesn't work. But we should focus those experiments in unit testing in a particular way, in integration testing in a completely different way, in system testing a different way again, in acceptance testing a different way again, so that those tests are more focused on what they should be trying to find out.
And with that, we are out of time. Thank you very much.
Thank
Well
you.
done.